Okay, we're going to look at section R6 here. And what R6 is going to do is going to kind of put together a lot of what we've been talking about, but it's from a non-graphing perspective. So we're going to look at a lot of these rational or these fraction looking expressions, but we're not going to graph them. So we're going to spend a lot of time simplifying. Because of that, they're not always going to ask you for the domain. But I want you to always think about the domain, because if we were to graph them, that's the number one thing you'd have to consider. So they're going to warm you up by asking domain, but they're going to kind of stop later, but you're going to still start thinking about it as you go. Okay, so they want the domain of this expression. Yes, it is an expression, even though it looks just like a number to you. There's no x. Okay, remember when you're talking about domain, you're looking for risk factors. Is there any risk factor of this dividing by 0 having a negative under the square root? No, there's not. That 9 can never be 0. It's 9. So because of that, the domain is all real numbers, and there are no numbers excluded. Now, this one's a little bit different, because you know that the risk factor for domain here is that you cannot divide by 0. So that cannot equal 0. So then you're looking at x squared plus 8x plus 15 not equaling 0. And we've seen quite a few problems like this. We're going to have to factor to figure out what would make x 0. So you'll make your list for 15. You're looking to get to 8. It's not 1 and 15. How about 3 and 5? Yeah, that will give me 8. So it's an x plus 3 and an x plus 5. But that cannot equal 0. So then you have to think about the 0 product property. What would make it 0? Well, this guy cannot be -3, or that would be 0, and this guy could not be -5. So it could be a real number, but it just cannot be those two things, -3 and -5. You'll like the way that they're having you write these in instead of what it can be. It's a little bit nicer than the other section. All right, so what about this guy? They want the domain here. Well, the top isn't the problem. The top can equal 0. It's the bottom that cannot equal 0. And this one is a very busy little guy here, because you have two things, or two different factors, and it's not even factored completely. But we can factor it further. So you have to be good at recognizing this, guys. That's x squared minus 9 is a difference of two squares. That's the same thing as x minus 3, x plus 3. This one you would have to guess and check with your list of -15, 1 and -15, 3 and -5. That gives me -2, so I'd have to change the signs to -3 and +5. And now we have to see what would make it 0, because that would be things that would not be allowed, and we don't want this to equal 0. So the first guy, x cannot equal 3, because that would make this 0, and it can't be -3. And then this one is already counted. These are the second. That would be a double root, so that is already counted. And then x cannot equal -5 for the last one. So there are 3 numbers that are excluded from the domain. That's not allowed to be 3, -3, or -5. Okay, now they're not asking us for the domain here, but I want you to still think about the domain. They're just asking us to simplify. They want us to simplify by removing factors that would cross out to simplify to 1. So on these, you're going to factor everything, the top and bottom. And removing these factors, what you're actually doing, if you were looking at the graph, is you're trying to find where the holes would be. So let's factor the top and the bottom. The top would be r plus 8 and r minus 8, because I told you to be good at that. That's the difference of two squares. The bottom, if you factor and you make your list for 64, the numbers you're going to get to -16 are -8, -8. So the bottom will be r minus 8 and r minus 8. Now, if I'm going to do the domain, which they're not asking me to do, but I just want you to practice thinking about it, r cannot equal 8. Now, if I was asking you for the vertical asymptotes, which I'm not, a lot of times you guys think, oh, vertical asymptotes, it's the same as the domain, but not always, because look, this r minus 8 and this r minus 8, those will simplify out, and there does leave 1 underneath. So actually there is a vertical asymptote here at r equals 8. But we cross out that 1 pair, and this is what they want us to put in here. They want us to simplified form, and they want us to make a fraction here. And on the top, it's going to be r plus 8. On the bottom, it's r minus 8. So they just want you to factor everything and look for one pairs. All right, what happens here? Well, the numbers are bigger, which is disappointing. But remember, you should always look for GCFs. If you can find a GCF, it'll make your life a little easier. So let's pull out a 5 on top here. If I pull out a 5, I have an s squared plus 6s plus 9. And on the bottom, I'm actually going to pull out a 25. And I'm going to have an s squared minus 2s minus, how many quarters are in 375? 12. There's 15, I think. Okay, now we still have to factor. Factor the top, factor the bottom. So you still have the 5. I make a list for 9. I'm trying to get to 6. 1 and 9, 3 and 3 is what I need. So it's an r plus 3 and an r plus 3. And in the denominator, I still have the 25, but you make your list for negative 15. 1 and negative 15, 3 and negative 5. That's what I need. An r plus 3 and an r minus 5. Okay, so again, let's talk about domain here. R cannot equal negative 3 or 5. That would divide by 0. And we're looking to simplify. Now, these r plus 3s would cancel, which means if I would have graphed it, that negative 3 would not be a vertical asymptote. The vertical asymptote would be at 5. The negative 3 would have a hole, because remember, if you simplify it out, it's a hole. And then you have the 5 and the 25 that can simplify out. So 5 over 25, that's the same thing as 1 over 5. And basically, you just write in this little box what is left when you simplified out all those 1 pairs. So what did we have? We have on top, we saw the 1, but I don't need to write that. Let's just write the r plus 3. And on the bottom, now I have a 5. Don't forget that 5. Some of you will. And I still have the r minus 5 that did not simplify out. I don't know if they'll want us to change that to 5r minus 25. Let's see if they want us to or not. To factor the numerator and denominator and divide the numerator and denominator by the greatest common factor. I feel like I did that. Let's see what they want here. I got the r plus 3. The 25, and one of the r plus 3's cancel. Let's see if they want this to say 5r minus 25. Maybe I factored it wrong. Pulled out the 5. Nobody's here to help me. S squared plus 6s plus 9. It's 5s squared. Who's here? Hi, Matthew. Oh, I'm doing this problem to see what happens here. 5s squared plus 30s plus 45. 25s squared minus 50. Let's see. Maybe I did that wrong. What's 25 times 15? 375. That looks okay. And I factored r plus 3 on the top. 25, r plus 3, r minus 5 on bottom. I like that. I don't know what they want us to put. I feel like I did good. I'm on question 5. I'm going to view an example here to see what they want me to do. I factored, did that. Factored, did that. Pulled out the 2. They wanted you to leave it in factored form. Yep, I'm doing r.6, yeah. Yep, that's what I'm trying to do. 5r minus 5. I don't know what they want to put. Let's see where I made the mistake. We're going to have to do this one again, because it's not going to like what I have here. Oh, dogs. Okay. Make sure I put R's. I changed my S's to R's. So really be careful with your variables there, guys. Okay, so my answer was correct with the wrong variables. I'm not going to do the question again. Make sure you have the correct variables in your answer. Okay, a lot of times we default to x's. All right, so we're going to go to number 6 now. So when you're simplifying, all you need to do is factor the top and factor the bottom. And you're looking for like one pairs that you can simplify out. Now, on the top here, you have 3 minus x, which is a little weird because we're used to seeing it look like x minus 3, and that's going to come into play in a second, okay? But when you make the factors for the bottom, you make your list for negative 24, 1 and negative 24, 2 and negative 12. It's going to be not 3 and negative 8 because that gives me negative 5. It's going to be negative 3 and positive 8. So I'm using x's. I want to make sure I don't mess that up again. And x minus 3, excuse me, and an x plus 8. So that's factored. Now, they're not asking me for the domain, but I do want you guys to really think about domain on all of these. That means x cannot equal 3, and x cannot equal negative 8. So it might look like there's nothing that can cancel out. But in fact, this 3 minus x is very closely related to x minus 3. So the rules with these are you can cross them out if they're kind of opposites that way. But since they're not the exact same and they are opposites, when you simplify them out, you have to replace it with a negative 1. So because they're not the same and they're opposites, when you cross them out, you have to put a negative 1 in its place to balance. So this does simplify to negative 1 in the numerator spot and x plus 8 in the denominator, because that 3 minus x and the x minus 3 can simplify if you replace it with a negative 1. Did you factor the bottom? Okay, so the x minus 2 will cancel with the 2 minus x, and that will leave you with a negative 1 in its place. And whatever factor you had left on the bottom is what you would have. Yep, I'm just simplifying. No, you don't. When you simplify them out, because they're not the same, in order to cross them out, you have to put a negative 1 in its place. Because they're not the same. They're opposites. Negative 1 over the bottom factor that's left. All right. Now, we're talking about multiplying now. And multiplying is just as easy as simplifying, because actually the rules with fractions, just a reminder, if you have 2/3 times 3/5, you multiply the tops and you keep them on top, and you multiply the bottoms and you keep them on bottom. But because that's the way it is, it's almost like it's a super fraction where everything on top is the same and everything on bottom. So if you want to simplify before you multiply, you could do what they call as cross cancel, which kids get confused with cross multiplying. But anything in the top can simplify with anything on the bottom. And it can save you from having to simplify at the end if you notice it early. So what we like to do on these is we like to factor everything. And then you look for one pairs with anything on the top, simplifying with anything on the bottom. Right. Well, first let's factor. First, let's talk about it. Yours will be similar to mine. This is the difference of two squares. A squared minus b squared can be factored to a minus b times a plus b. You can't do anything until you factor. Now, the second guy does not factor that a minus b on top, so that just stays. The bottom is technically already factored, but they didn't expand it out. It's the same thing as a minus b times a minus b, and then this would be a plus b. And all of these are factors. So anything on the top that has a pair on the bottom, you'll be able to simplify out. So these two can simplify out because they're both a minus b. Then I have this a plus b here that can cancel with this a plus b there. And then I have this a minus b that cancels with this a minus b. And I actually have everything canceling out for me, which gives me just 1 as my answer. You can't have 0. If you cross everything out, you get 1 over 1. And everything simplifies out.
Do you do r minus s times r minus s?
Yep.
And then you get r squared minus r plus s squared.
No, you don't expand it back. You just leave it in factors like I did. R minus s, and you just look for pairs to factor. You don't expand anything here. You're simplifying. You're looking to cross out factors. Yep. So everything should cross out. You cross, if you find a pair, like here's 2a minus b, so they cancel out. I can't cross these out because they're not the same. But this one is the same as this one down here, and anything on top can cancel with anything on bottom. Okay, on these that have lots of different factoring ones, we're probably going to have to come back to. If you can't get it, just leave it, and we'll come back at the end so I can stop the video and get your problems that you get stuck on, okay? All right, so this is the exact same thing. Multiplying and simplifying. First, you have to factor everything, and then you have to look for one pairs. Now, because this one doesn't have 2 different letters, it has 1 letter on the test. If you have one like this, I'm going to ask you to do the domain as well, because I always want you guys to start thinking about that domain. So we're going to factor everything. So there's actually 4 factoring problems here. So when you make your list for -9 for the first guy, 1 and -9 gives me -8. I need -1 and +9. So that's my first numerator. And on the denominator, if you make your list for -5, I want 1 and -5. No, I want -1 and +5. Okay, so that's my first fraction. I'm going to multiply that by this guy after I factor it. And I make my list for -10, looking for -3, and that's it right there. So it's going to be an x plus 2 and an x minus 5. And on the bottom, when I make my list for 18, I'm going to use 2 and 9. Okay, so you factor all of your problems. That's the first thing you're going to have to do. Okay. So, like I said, on your test, I'm going to ask you for the domain on this as well. And x cannot equal, you just have to look at the denominator. X cannot equal 1. It cannot equal -5. It cannot equal -2 or -9. And even though some of those pieces are going to cancel out, you have to look at the domain first. Because those places where it cancels out are going to be holes, but they're still part of the domain. So that will be the domain. And now we're just looking for 1 pairs. And since I have an x minus 1 on top with an x minus 1 on bottom, that would simplify out to a 1 pair. This x plus 9 can simplify with this x plus 9 over here. And then I have a pair of x plus 2s that can simplify out. Everything else stays as part of your answer. So when I multiply these guys, everything actually ends up breaking out except the x minus 5 in the top. And in the bottom, the only thing left was an x plus 5. So lots of factoring on those and lots of simplifying. Okay, and if you, like I said, if you didn't get that one, Matthew, just leave what you have and then we'll get back to it at the end. Okay, so now I'm going to go to question 10 or 9. And this time we're dividing. Now, when you divide, you need to know this about the domain. When you do the divide for the domain, you have to check the domain first and at the end. For division, you do have to check the domain 2 times. Because if you remember how to divide fractions, I think Mrs. Dorn taught a lot of people that. She said keep, change, flip. We actually multiply by the reciprocal. So what happens is we will multiply by this guy after it's flipped upside down. Keep the first guy, change the sign, flip the second one. Okay, so we have to, though, do the domain first and last. So let's see what happens here. Let's go ahead and factor everything you have. There's a GCF in the top of a 2. That leaves me with an x plus 3. GCF of a 3 with an x minus 3. Now, it's divided by, this guy's already factored up for me, x plus 3, x plus 3, and x minus 2, x minus 2. So when we do the domain first, we know that x cannot equal 3 or 2. But when I'm actually doing the math, I'm now going to change this problem to 2 over x, I said that wrong, 2 times x plus 3 over 3 times x minus 3. So I keep that, change this to multiplying, and flip the second guy. X minus 2 over x plus 3 and x plus 3. And if you can see, now I'm going to have to add negative 3 to my list of domain things because now those guys are in the bottom. So domain is tricky on that. We will have practice before you take your test. I am going to ask you for the domain problems on your test. After you set it up, the problem is easy. It's like basically playing go fish. You're just looking for pairs. So this x plus 3 will simplify with this x plus 3. For me, I have nothing else that will simplify. The 2 will not simplify with anything. The x minus 2 will not simplify with anything. And so basically, I'm stuck. So when I write this and they want it in factored form, I just have to write all the things I have left. So I have a 2 left. I have an x minus 2 left. And you can write it out twice, I suppose. I don't know if they're going to want me to write that like x minus 2 squared or not, but we'll try it like that. And then I have a 3. And I have an x minus 3. And an x plus 3. What do they want me to put? It is x's. Maybe they want me to put the x minus 2 squared. Hmm. 2x plus 3. Oh, here it is. Look, when I pulled out the 3, look at what I did. When I pulled out the 3, this should have been an x minus 2. And since this is an x minus 2, excuse me, one of those x minus 2's would cancel out. So now I just have a 2 with an x minus 2. So Bruno factored that wrong. I don't know how to get rid of it. That little blue box thing there. And now I just have a 3 and an x plus 3 left. So I did some bad factoring. That's right now. So be careful on that one because I messed that up when I pulled out my GCF. Okay, and like I said, if you still have questions on that one, I'll help you in a minute. All right, this one is tough. This one is tough. It asks you to do a whole bunch of factoring patterns. It has multiple letters, and kids don't usually like this. So let's see what we got here. Z squared minus w squared. It's multiplying, so I don't have to flip anything. This is difference of two squares, so that's z minus w and z plus w. This guy actually does not factor. Z squared plus zw plus w squared does not factor. The bottom piece, though, does factor. This is called the difference of two cubes, and it's been a while since you've seen this. And the rules for two cubes is this. If it's x cubed minus y cubed, what we do is we take the cube root, we keep the sign, and you take the cube root. After you do that, you square the first piece, you square the last piece, and you multiply those together and change the sign, so it's a plus xy. So that's what we're going to do here with the z's and the w's. So first you'll take the cube root and the cube root. You'll square the first piece, which is z squared, square the last piece, which is w squared, multiply them together and change the sign, so it's plus zw. And on the bottom, that also factors, that's the same thing as z plus w times z plus w. So there will be a lot of things that can cross out here, assuming you could do this difference of two cubes right. I think a lot of kids will ask me questions on number 10, but everybody's problem should be very similar. First of all, the z minus w's will cancel. And then this big piece here will simplify out with this big piece here. One of the z plus w's will simplify, and then you have nothing left on the top except a 1. And on the bottom, you would just have a z plus w. So you have a 1 on the top and a z plus w on the bottom. But those are some hard factoring patterns. I'll have to double check to see if that's going to be on the test, because you might need some more practice on that before we take a test on that, if that factoring pattern shows up. But after you factor it, both of those pieces will cancel out. Okay, so now about addition. You have done addition before. It's been a long time. And the rules with addition is you have to have a common denominator. Good news, you do have one right here, right? So there's a 7a in common. So you can just add the tops and the bottom stays the same. So that's 14 over 7a. However, that does simplify. They both have a 7 in common. So that would leave me with a 2 on the top and an a on the bottom. So it simplifies to 2 over a. You didn't have to get any factoring there, just that 14 and a 7 would simplify. Okay, question 12. Before you find the common denominator, you're going to have to factor first. So we're going to find the common denominator. By factoring. So the first one does not factor. That's fine. The second one does. You have the 4 here, and down below you have an x plus 4 and an x minus 4. So we cannot add these until you get a common denominator. So we talked about common denominators earlier this year. We're talking about what we can change everything to. And x plus 4, x minus 4 is going to be the common denominator. So this guy gets to stay put, but this one had a piece missing. So what was missing? Well, what was missing was the x minus 4. So I have to multiply the top and bottom by x minus 4 to get the common denominator. And now in the top, I have 5 times x minus 4. Well, that's the same thing as 5x minus 20. So if you add 5x minus 20 plus 4, I actually get 5x minus 16 over that denominator, which is x plus 4 and x minus 4. So if you're thinking about domain, x cannot be negative 4 and 4, but we can add those two fractions and simplify it out. We get 5x minus 16. Oops, I did too many of those. 5x minus 16 over x minus 4. Okay. Looking at question 13, we're now doing subtraction. Subtraction is very similar. You still need a common denominator, but you have to be careful when you subtract. You have to subtract all of the pieces of the second fraction. So we're going to factor first. If I make my list for negative 36, I want 4 and negative 9. So it's going to be a y plus 4 and a y minus 9, and that gives me a y on the top. Minus. Now the second piece is missing. It has the y plus 4, but it still needs the y minus 9. So I'm going to take the top and the bottom by y minus 9. So I have a minus 4 times y minus 9. So we just clean it up a little bit. So that's y still, y plus 4, y minus 9. And you have two choices here. You can actually distribute the negative 4, or you can leave it as a minus and say that's what, 4y minus 36 over y minus 4, y minus 9. And now when you put it together, you have to subtract both pieces. So it's y minus 4y plus 36 over y plus 4 and y minus 9. So that gives me negative 3y plus 36 over y plus 4 and y minus 9. See if they'll take that. Okay. All right, so on this one, this is similar to what we were just talking about a minute ago. It's one of the easier problems once you know the rule. You have to have a common denominator, and you don't. So the rule is you couldn't simplify them without changing it to a negative 1. If you want to change it, you have to multiply the top and bottom by negative 1. So if you want that to change, I can, but now it's a negative 9 over y minus 5. And now it's just easy because the denominators are the same. And instead of a y plus 9, it has to be a y minus 9. Because if you want to change the way or the order of those denominators for y minus 5 to 5 minus y, those are actually opposites. You have to multiply by negative 1. Okay, this one is very similar. If you want to change those, change the order of it, you would have to change this to a negative 1. So it'll be a negative y, so then it would be x minus negative y, which becomes an x plus y. And then you can change the order of the 7x minus 2y. So this problem is very, very similar. You'd have to multiply the top and bottom by negative 1. Okay, what's that say? This is an adding one, and this one has some GCFs to look at. So this will be a tougher common denominator problem. So let's factor everything. So there's a 2 in common up the top, and that will be a 2v plus 1. I think I factored it right this time. On the bottom, there's a GCF of 3, which would be v squared minus v minus 20. But that can factor further. Negative 20, if I use 4 and negative 5, that will give me negative 1. So that's v plus 4 and v minus 5. Plus, I have a 7 here. These have a 3 in common. That's a v squared minus 6v plus 5. That can factor further. That's a v minus 5 and a v minus 1 over 7. So the common denominator here, we need something they all have in common. So they have a 3 in common, so we're going to keep that. This one has a v plus 4, but this one does not. So I'm going to have to take the top and bottom of this times v plus 4. This one has a v minus 5, well, so does this one, so that's good. That's part of the common denominator. And then this one has a v minus 1, but this one does not, so you're going to have to multiply the top and bottom by v minus 1. So the whole common denominator is going to be all those pieces. And now we have to add the like terms. Well, this will be, you have to clean it up, first of all. We'll have to clean it up. So this is 2 times 2v squared minus 2v plus v minus 2v plus v is a minus v minus 1. So that's what? 4v squared minus 2v minus 2. And then this is plus 7v plus 28 if you distribute. So on the top, I'm going to get 4v squared minus 2v plus 7v. I believe that's plus 5v. Negative 2 plus 28 looks like a plus 26. Okay, I don't know that that factors. I don't think it does. Let's see if it will take the answer. It's kind of a hard one. This one is kind of messy. So 4v squared plus 5v plus 26. On the bottom, all those factors. 3 plus 4 minus 5 minus 1. Okay, they took it like that. So you can find a fancy common denominator and then just clean up the numerators and add them. Okay, I think this is enough today. We'll talk about these big, harder ones, 17, 18, 19, and 20. We'll talk about those in class, okay? So if you can make it through, what did we say? Make it through 16, you'll be in pretty good shape.